Exactly. How would you say this in English?
The inverse function of x.
Inverse function of g. I like it. Or just directly, you could just say g inverse of x is this.
Yeah, but the other one, like the g inverse.
So g inverse of
G
of x. I like it. So g inverse of g of x.
Oh yeah, because at the end I confused it, so I thought we were going to put in the negative inverse into the original one.
Sure, and that would still be a good check. That's not what this is asking you to do. If you ask yourself, what is inside of the other thing?
That was one.
G is inside of g inverse. So you want to take g and put it in g inverse. That's specifically what this is asking for. If you do this, it's still a good check. But that's not what this was asking for you. I like it. What would this still come out to be? X. Because these would kill each other, that still has to be X. It doesn't matter who you put inside the other dude. If it comes out to be X, you're good. Alright, maybe. Alright, just a little bit more, guys. I know every day it's kind of like, oh my God. When's he going to let us out?
What section are we doing right now?
You lost those 2 days, so no more early shit for us. Yes?
What sections are we doing right now? Is this 12.1?
Yeah, this is still 12.1. 12.1 is all about composition functions and then inverse functions. And one reason we did composition functions was because of this step right there. That's how I check my inverse work, is by using a composition function. Okay. So, for a minute, we're going to go away from this, introduce a new function, and then we're going to immediately apply some of what we just did to figure out what its inverse is going to be. So I know this is not new to some of us, but let me introduce this in a weird way. So we've added stuff to x, we've divided x by stuff, we've raised x to various powers. I mean, what else have we done? We've done roots, we've raised x to fractional powers. Sure, we've multiplied x by stuff. Right, we've done a lot of things. Something we have not done. We've even put x on the bottom of shit, right? We had the whole section about rational expressions. So the one place, or one of the most obvious places we have not put the x yet, is related to this one. So when we did this, we let the base be x, and we kept the power constant. So we're always raising the input to the fifth power. Well, we could reverse that. What if we made the base constant and raised it to different powers? So what I mean is, instead of this, what would it look like? Let me make the base a little bit better than 5. What if it was 2 to the x? Now, where's the variable in there? In the exponent. So what, knowing how creative math people are, what kind of function do you think that would be?
Inverse.
Where's the variable? Exponent. So what kind of function do you think we'd call this?
Exponential.
Exponential function. Oh, that's crazy. I like it. There's a slight difference when I say the exponential function. We'll get there. That's a specific one of these dudes, right? The base could be something, whatever. Just like the power here didn't have to be a fifth power, but the minute it's a fifth power, it's always a fifth power for that function, right? So the very first thing I want us to do, and even though some of us maybe have never seen this before, how many guys have ever worked with exponential functions before? Anybody? Some of you guys are like, I'm not going to say yes, because then I'm not held to any standard. All right. Even though we've never seen this before, we know how powers work. So complete this for me and then try to graph it. These are my go-to 5 points for any function. I don't know what it looks like. I start with those points. So everybody see what's happening now. I want you to take this function and I want you to use these inputs. So what would it look like when I put a -2 in? It would be 2 to the -2 power?
4.
Oh.
No, 1 over 4.
There it is. All right, now, so finish this out and then try to graph it. So even when you get a new function, as long as it involves an operation you know, you can always make an XY table to at least see what it looks like.
1 over.
Because the negative power is going to make it flip. So when you plug a -2 in, it's going to become 1 over. 4.
But the 1/2 has been used, so to speak.
So what does it say? It says flip it and then square it. So this will be 1 over 2 squared. 1/4. Cool. If you ever watch horror movies or like movies with like a virus that spreads, zombie virus or something, say it's going to spread exponentially. So they show here's where it is now, here's tomorrow, and then the next day it's the whole world. Holy shit, Johnson! Gotta get to Raccoon City. All right. So let me see. This shouldn't take too long. I'm hoping. Each one is just plug a -1 in the power and then do what it says. So that would be 1/2. Plug a 0 in the power. What's anything to the 0? 1. 2 to the first power is, oh my god. 2 to the first power. Now 2 squared is 4. Now, has anybody tried to graph it yet? You got a bunch of points. Plot them. Don't even connect them yet if you don't feel comfortable. You got to figure out what the hell's going on with this. Looks a little freaky. Alright, so I got the point. What's the first point I got? Yeah, -2. And then 1/4, you can think of it, here's 1/2, so 1/2 is half of that. 1/4 is half of that, so there's 1/4. Bam! How we done so far? And then -1, 1/2, 0, 1, 1, 2, 2, 4. 3 would go to 2 cubed is
8.
because remember, what's this function? This function says the base is 2. So when I plug a 3 in, it'll be 2 cubed, 8. Right? So 3 would go to 8. 4 would go to 16. So that's what it means. It's growing exponentially. It's bad news if it's a freaking blob monster that's eating people, or if it's a spread of a virus. The fact if it's spreading exponentially, that's bad. This is like bam, bam, bam. He's like, holy shit, wow. All right. So this side is pretty simple. The bigger the numbers I put in there, the bigger that's going to get really pretty quickly. This side is kind of freaky. What the hell? Is it ever going to go through the x-axis is a good question, right? So if you think about it, even if I did 2 to the -1 billion, what is that going to be 0?
No, it's going to be 1 over.
1 over 2 to the 1 million. So it's going to be 1 over big ass number, which is it big or small? The result. 1 divided by really freaking big is really freaking small, but it's still positive, right? And that's going to be true no matter how many zeros I plug on this thing. It's going to just get smaller and smaller and smaller and smaller. So I don't know, who knows what that's called when there's something you keep getting closer and closer to, but you never quite reach it. It's called college. No, it's called, sometimes it feels that way. It's called an It's called an asymptote. I like it. I don't know if you guys ever heard of that. Asymptote. It's asymptotic. So an asymptote means that there's a thing that's getting really close to you. You normally put a little dotted line to show it's getting really close, but it never gets there. So if I went half the distance of that wall, and then I went half the remaining distance, and then I went half the remaining distance, and then I went half the remaining distance, would I ever actually get to that wall? No. It's called Zeno's paradox. Anybody ever heard of Zeno's paradox besides the fact that you said? So when my instructor told me, the actual paradox is you have Zeno go to the next town. But to get to the next town, he's got to go half the distance, doesn't he? And then he's got to go half that distance and half that distance. So he never makes it to the town. So when my instructor said that, I said, being the smartest I am, I said, tell him the town is twice as far as it actually is. So then he's freaking there on the first one. And then my instructor, but that's, you can look it up. It's an actual thing. Zeno's paradox. Z-E-N-O. And sometimes it's X-E-N-O. It depends on where you're from. Blah, 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 blah. So this is what, no matter what the base is, what would be different if I made the base 3?
Faster.
Yeah, it would go up faster. Right? Because 3 squared is 9. 3 cubed is 27. Right? And it would also go down faster. I like it. You guys kind of with me? So the bigger the base is, the more this thing goes like that. But it's going to still have the same shape. It's like a parabola. There's a lot of different parabolas. They can open up, they can open down, but they all like a freaking U. They're all a U. The vertex moves around and shit, right? But they all look like this. Every single exponential has this shape. I like it. All right, maybe. Maybe. I like it. Some of you guys are like, I'm jealous of that person who just left. That's too bad for you. Don't have the balls to do it. You just got to sit there. Okay. So now that I've got this picture, this is the last thing I'm going to talk about. But it's going to take about 30 minutes. I'm joking. Now that I've got this, and I've got the function staring me in the face, I don't know what the inverse function is going to be. If I said, what's the inverse function of this?
X to the 1/3.
Yeah, I love it. X to the 1/3 would be the inverse, or the cube root. So I know what that function inverse looks like. I've given it a name. I've given it a symbol. So we can graph the inverse function of this. We then still have to give it a symbol. I don't know if you guys really see what I'm saying. So if y equals x cubed is the cube function, then x equals y cubed represents the inverse. But see, that's crappy. If we never came up with the cube root, that would kind of suck. I'd have to talk about the answer I couldn't say what's the cube root of 27. I'd have to say, what do you cube to create the number 27? I have to kind of say this. I want one symbol that means that statement. So here, how would I graph the inverse? We know how to do that. How do I do it no matter what? How would I graph the inverse? Switch the x and y. So then my inverse function would go through what points?
2, -2. Oh no. 1/4.
Careful. 1/4, -2.
1/2, -1, 1, 0, 2, 1, 4, 2.
Thank you, sir. All right, cool. So then the inverse will look like 1/4. So it's going to be here. 1/4, -2. 1/2, -1. 1, 0. 2, 1. And then 4 is up here. 2. So it's going to look like that. And is that where we would expect it to be? Where's the mirror? Right where it's supposed to be. Y equals x, right? Right down the diagonal. I like it. So that makes sense. The asymptote used to be along the x-axis. Now it's along the... Which makes sense because everything flips. All the x shit gets flipped to the y shit. So wherever the asymptote is, if it was x equal 2, y equals 2, now it's x equals 2. The asymptotes just flip the same exact way. It's kind of nice. So we know this function is 2 to the x. We just haven't given this function a name yet. And this is another situation where you might think, oh God, why wasn't somebody there that day to help, right? Because this, I haven't said anything about this yet. But does anybody know what function this is?
F -1 x equals to,
That's the problem. See, if I want to say f inverse of x equals, I have nothing to put here yet. We haven't come up with it. So I really want this to make sense. When I have f of x equals x cubed, I can write f inverse equals cube root of x, right? Come on now, say with me. The opposite of x cubed is cube root of x. You with me? But we had to come up with this symbol. We had to make this symbol up at some point. Aliens didn't give us this shit and say, you'll do it this way or we'll come blow you up. We came up with this ourselves, and we said, this means the opposite of this. Oh. So we had to come up with a symbol, and it could have been a box with a 2 in it or something to represent, but it wasn't. What they chose is based on a Latin word for the study of numbers, logarithmos. So it's a logarithm. So the inverse would be log base 2 of x. So the freaky thing about this function is it's the very first function we've ever seen, for the most part, for most of us, where it has a little word in it. And it could have been this, right? That could have been the function. But it looks too much like x divided by 2. It could have been anything. Why does this have a little, looks like a division symbol on it, really? Why? Because somebody in history said, this is what it is, and this is what it means, and everyone went, sounds good. And one guy disagreed, they killed him, kept going, right? Which sometimes wasn't too far from the truth. The history of math is very bloody. Okay. So what does this mean when I see this? Well, when I see this, f of 3 equals 2 cubed, this means make there be 3 2's, right? That's one way to look at it. Not just 1 2, I want 3 2's multiplying. And I get 8, right? Which means, now stay with me. I really want this to make sense. So if f of x is 2 to the x, then f of 3 is 2 cubed is 8. So what must, if f inverse is log base 2 of x, what must log base 2 of 8 be? You can do it. It's got to be 3. So what's the question this is asking? This says, make this the power of 2. And then we get 8. So the question this is asking is, what power does 2 need to become this? That's the important thing about functions. When you learn functions, you have to think, what is the sentence that the symbol means? So when I see square root, I know that means, what does it take 2 of to multiply be this? I know I've internalized that question. So when I see the symbol, I translate it without even realizing that's what I'm doing. So when you see this, what power does 2 need to become 8? What do I raise 2 to get 8? To the third power. So the answer is 3. Once you realize the question, the problem is easy. Everybody hates logarithms. I don't understand why. If you know what it's asking you, you know how to do it. We've done this before. So like this, let me just give you a couple. What's log base 3 of 27?
9.
Come on now.
3.
3. You got to force yourself to realize it's a power that I need. Or you can say to yourself, how many 3's do I multiply to make 27? 3. Because that's what a power does, right? I know 3 times 9 is 27, but why would I make a logarithm if it meant division? I already have division symbol, right? It must mean something else. So what about, what's log base, what do you got, Jeff? I don't know, man. 2 of 32.
16.
No, come on, see? So you're not dividing. You're not dividing.
5.
5. Why is the answer 5?
Fifth power.
Because 2 to the 5th power is 32. How many 2's do you need to multiply to be 32? That's the question. I need 5. So it's related to this question, but it's not the same question really. Because what's changing is the root. I'm asking myself, or in this case, what's changing is the power. And I'm asking myself, what power is required? So the answer to a log will always be a power. Why do I make a big deal of that sentence? Because when we go to talk about properties of logarithms, they'll be the exact same properties as the properties of powers. They're exactly the why, because logs are freaking powers. That's why. So a couple more real quick. I'll give you a little more challenging one. What's log base 8 of 2? Yeah. 2 is smaller than 8, right? So you got to cut it down somehow. What powers cut something down?
1/3.
I love it. A 1/3 power, because what do you do to 8 to make it become 2? Take a cube root of it. But again, the question is the same. What power does 8 need to become 2? Well, I change it. If the inside number is smaller, I say, what root does this need to become 2? If it's the third root, then it's a 1/3 power. It's all about translating this into an English question. That's what it really is. One last one. What's log base 8 of 1? I love it. Again, what power does 8 need to become 1? The 0 power. I like it. All right, and I just lied. One more with log base 8 of 1/8. Negative 1. What power does 8 need to become 1/8? It needs a negative 1 power. All right, so tomorrow we'll pick up from there. We'll talk about the next few quizzes tomorrow.